All right, everybody, welcome to Math with Grace. Today we're going to be going through Algebra, Unit 8, Lessons 6 through 10. Lesson 6 starts on page 26, and it's entitled Box and Whisker Plots and Outliers. We will not be doing this lesson. So anytime you come up to a box and whisker plot and outlier problem, you can skip it. Now that's only going to apply to the homework going forward, because on quiz 2 and on this test, there actually isn't a box and whisker problem. So you won't have to worry about skipping anything on your tests. But if you come up to a box and whisker problem on your homework, you can skip it, because we will not be doing this lesson. All right, let's move on to lesson 7. Now lesson 7 begins on page 32, and it's dividing polynomials with remainders. Now, I'm not going to go into a huge explanation of how to divide polynomials. You can go back and check, I believe, Unit 7 for how we do dividing polynomials. But we will be talking about the remainders. Now, all of the dividing we did earlier, we didn't have any remainders. The remainder was always 0. But sometimes when we get to here, we have a remainder of -5, right? There is no way, well, at least the way to do it is pretty complicated, to make 4x minus 3 equal to -5, right? So -5 is our remainder. Now the book wants you to write it like this, with an r minus 5. But I don't want you to write it that way, because mathematically that's really not the correct way to do it. And if you move forward into like Algebra 2, that's definitely not the way they're going to teach it. So we might as well do it now the way they teach it in Algebra 2, because eventually, hopefully, you'll be in Algebra 2. So how you would write remainder of 5 in this class, because this is how I'm teaching it and this is how I want to see it, is instead of just writing r minus 5, you're going to write -5 over, and it's going to be whatever here. So 4x minus 3. This is the way that I want you to write the remainder. Now, obviously, this part's important too, but this is the way I want you to write the remainder. So let's jump into these problems and do some here. So we've got 2x squared minus x minus 13 divided by... So 2x squared minus x minus 13 divided by x minus 3, okay? So how do I get my x to look like a 2x squared? Well, I'm going to have to multiply it by 2x, right? 2x times x is 2x squared. 2x times a -3 gives me a -6x. I'm going to change my signs, okay? These cancel, beautiful. -x plus 6x is 5x minus 13, because my 13 drops down. And now how do I get this x to look like a 5x? Well, that's simple enough. I'm going to multiply it by 5. 5 times x is 5x. 5 times a -3 gives me a -15. I change my signs, okay? 5x minus 5x cancels, perfect. -13 plus 15 gives me a +2, right? That would be my remainder. And how we're going to write that is plus 2 over x minus 3. So my answer is 2x plus 5 plus 2 over x minus 3. There's 2 parts left of this x minus 3. That's how it becomes this fraction. Okay, just like with division remainders, there's 5 parts left of whatever you're dividing by. Okay, like in the example. So this is how we want to write these, okay? And it's kind of hard to put a box around my answer, but it's right there. All right, let's look at number 2. I've got a little bit more space over here. I have x squared plus 11x plus 30 divided by x plus 4. All right, so how do I get this x to look like an x squared? Well, I'm going to multiply it by x, right? X times x is x squared. X times a +4 gives me a +4x. I change the signs. X squared minus x squared cancels. Good. 11x minus 4x gives me 7x. Okay. My 30 drops down, so plus 30. Now, How do I get this x to look like a 7x? Well, I'm going to multiply it by 7, right? 7 times x is 7x. 7 times 4 is positive 28. Then I change my signs. 7x minus 7x is 0. 30 minus 28 is 2. That is the remainder. So I'm going to, and it's positive, so I'm going to write plus 2 over x plus 4. Okay, that is the answer in the way I want to see it. This prepares you for more maths. All right, let's look at number 3. We've got negative 8b squared minus 10b minus 12 divided by 2b plus 2. All right, how do I get my 2b to be a negative 8b squared? Well, I'm going to have to multiply it by a negative 4b, right? The negative 4 gives me my negative 8. The b gives me my b squared. So now I have negative 8b squared. Negative 4b times a positive 2 gives me a negative 8b. Okay, I change my signs. Negative 8b squared plus 8b squared cancels. Negative 10b plus 8b gives me a negative 2b. This negative 12 falls down. Now, how do I get my 2b to be a negative 2b? I have to multiply it by a negative 1, okay? Negative 1 times 2b gives me a negative 2b. Negative 1 times a positive 2b, or positive 2, sorry, gives me a negative 2. Change the signs. Negative 2b plus 2b cancels. Negative 12 plus 2 gives me a negative 10 as my remainder. So now I'm going to have minus 10 over 2b plus 2. Now, this could actually be reduced because the 2b plus 2 can be pulled out, but let's not worry about that right now, okay? Let's just leave it in this form, but know that, right, we can pull a 2 out of here, and so then it would be 5 over b plus 1, but we're not going to go there today, okay? This is enough of an answer for me today. All right, let's do number 4. We have 4a squared plus 6a minus 12 divided by, and this is kind of a tight squeeze here, 2a minus 4. All right, so how do I get this 2a to be a 4a squared? I'm going to multiply it by 2a, right? 2a times 2a gives me 4a squared. 2a times a negative 4 gives me a negative 8a. Change the signs. 4a squared minus 4a squared canceled. Remember, if these don't cancel, then you've got a mistake. 6a plus 8a is 14a's, and this negative 12 drops down. Now, how do I get my 2a to be 14a? Well, I would multiply it by a 7. 7 times 2a is 14a. 7 times a negative 4 gives me a negative 28. Change the signs. 14a minus 14a is 0. Perfect. Negative 12 plus 28 gives me a positive 16. So again, plus 16 over 2a minus 4. And again, this one can be reduced too, but we're not going to go there today. All right. So my answer is 2a plus 7 plus 16 over 2a minus 4. Okay. Number 5. We've got 3, I'm going to figure out where I'm going to write this here. 3x squared minus 9x minus 15 divided by x minus 4. So how do I get my x to be a 3x squared? Well, I need to multiply it by 3x. 3x times x is 3x squared. 3x times a negative 4 is a negative 12x. Change your signs. 3x squared minus 3x squared, gone. 9x plus 12x is a 3x. This negative 15 drops down. How do I get my x to be a 3x? Well, I have to multiply it by 3, right? 3 times x is 3x. 3 times a negative 4 is a negative 12. Change the signs. 3x minus 3x, 0. 15 negative 15 plus 12 is a negative 3. Squish it in there. So That's my remainder. So minus 3 over x minus 4. Okay? That's how I want these answers written. Last one, number 6. We have 30m squared plus 50m minus 110 divided by 6m minus 8. All right. How do I get my 6m to be 30m squared? Well, 6 times 5 gives me 30, and m times m gives me an m squared. So 5m times 6m is 30m squared. 5m times a negative 8 gives me negative 40 m's. Change the signs. 30m squared minus 30m squared, 0. 50m plus 40m is 90 m's, right? And this minus 110 falls down. Now, how do I get my 6m to look like 90 m's? Well, we would have to multiply it by 15. 15 times 6 is 90. So 15 times 6m is 90 m's. 15 times 8, negative 8. 15 times negative 8 is a negative 120. Then we change the signs, okay? 90m minus 90m is 0. Negative 110 plus 120 is 10, right? Positive 10. So we've got plus 10 over 6m minus 8. And there we go. Like I said, we're not going to worry about reducing our remainders for now. Let's just write them out as they need to be written out. Okay, so long division, just like we've been doing. When we get to a remainder, though, we are going to write that number over what we are dividing by. And that is the proper way, mathematically, going forward, for us to write our remainders. All right, good job. Lesson 8 begins on page 38, and it's called Lowest Common Denominator. And it says here that adding and subtracting numerical fractions with unlike denominators requires finding the lowest common denominator, the LCD. This is done by finding the lowest common multiple, LCM. A lot of abbreviations. They can sometimes get confusing. But basically, we want the smallest number that both of them go into to be our common denominator. Now, the way the book shows it, here we have 1 over 12 and 1 over 18. They find the factors of each, multiply them, you know. To me, this process is a little bit tedious. Here's how I usually do these kind of problems. 18 is the larger of the two denominators, right? The larger number. 12 does not go into 18 evenly, so then we take a multiple of 18. So 18 times 2, right, is 36. 18 obviously goes into 36 2 times. 12 goes into 36 3 times. Okay, so we would have to multiply this numerator by 2 and this numerator by 3, and then we would be able to equal these out, right? They would have the same denominator. Right now, it looks like we are only trying to find the lowest common denominator. To me, this method is the easiest. Choosing the largest one and multiplying it by its, increasing it until the other one fits in. That's how I like to do these. To me, it's a little bit easier. If you want to use the factor process, then you go ahead and you find the lowest common multiple with the factoring process, prime factors. No problem. That works as well, obviously. And it says that that same process can work for rational expression. However, it involves factors that are numbers, variables, and sometimes polynomials. So for this one here, I would first look at the coefficients, right? 15 is larger than 9. 9 does not go into 15. So what is 2 15s? Well, 2 15s is 30. 9 still doesn't go into 30. So 3 15s is 45. 9 does go into 45, so 45 is going to be numerically my lowest common denominator. Now let's look at the variables, right? Here we have an x squared and an x. Well, x squared is the largest, and x goes into it evenly, so x squared works. What about the y? Well, this y to the third is the largest, and y goes into that evenly, so y to the third. So that would be our lowest common denominator. Okay, again, you can break it up into prime factors and figure it out that way. Fantastic. Okay, either way works. Let's zoom up here to the top of page 39. And in this case, okay, first we have to factor, and that's what this note was at the bottom, rational expressions with polynomials must be completely factored before you can solve them, okay? So factoring this one here, okay, the 12x to the third minus 6x squared factors to be this. Then you have to factor this 8x to the third minus 4x squared, and you get this. Okay, so now here are our two factors. Now, how do we choose these? Well, 6 is bigger than 4, right? And 4 does not go into 6 evenly, so 2 6s is 12. 4 goes into 12 evenly, so that's our coefficient. They both have an x squared, so that's pretty easy. And they both have a 2x minus 1. All right? Now, if this was a 2x minus 1 squared, then we would need the square because that's the bigger of the two. But it's not in this example. So that would be our lowest common denominator. Aside from stretching it all out with prime factors. Now, like I said, the prime factor method is what works best for you. Please do that. Let's take a look at this last example here, number 4. The denominators are x squared plus 4x plus 4 and x squared plus 5x plus 6. So those things need to be factored, and they become factored here and here. Okay, so this is what's in the first one, and this is what's in the second one, factored. So for our x plus 2, because they're combined with that plus sign, they are one chunk. This denominator has 2 of them, and this has only 1. So we need 2. So we need 2 x plus 2's. And we need an x plus 3. Even though the first one doesn't have it, the second one does, so we need it. So this becomes our lowest common denominator, all right? We need one part of everything, at least. Just because this one didn't have an x plus 3, this one does, so they both have to share it, right? All right, so let's do these problems together. We're not solving them all the way. They only want us to find the lowest common denominator. So for number 1, we have 2 and 6, right? 6 is larger, 2 goes into it evenly, so 6 is our coefficient for our lowest common denominator. Looking at our x's, x squared is bigger than x, so we get to choose the x squared. And y to the third is bigger than y. So that is our lowest common denominator. Without having to solve for prime factors and stuff, that's it, okay? Let's look at number 2. Now, number 2, there is some factoring required, right? So what do these two terms have in common? Well, they have a 4 and a y in common, right? And that leaves an x minus 2 behind. Looking at this other fraction here, a rational expression, our denominator, what do they have in common? Well, they have a 2 and a y in common, and that leaves an x minus 2 behind. So now, what do these two sets have in common? Well, coefficient-wise, I have a 4 and a 2. 4 is largest, 2 goes into it evenly, so 4 is definitely going to be my coefficient. They both have a y, perfect, and they both have an x minus 2, perfect. That is my lowest common denominator, okay? Number 3. 10m to the third n and 15m squared n squared. So 10 and 15. 15 is larger. 10 does not go into it. 2 15s is 30, and 10 goes into 30, so 30 is our coefficient. M to the third is bigger than m squared, so we're going to choose the m to the third. And here I have an n and an n squared, and n squared is larger. So, boom, done. All right. Like I said, you can break these out into their prime factors, but to me it just takes quite a bit longer. But if that's what works best for you, then I don't want to interrupt your flow. Number 4, 2x plus 2y and 6x minus 6y. Well, both of these can be factored, right? For the first one, I can pull out a 2 and it leaves x plus y. For the second one, I can pull out a 6 and it leaves x minus y. Looking at the coefficients, I have a 2 and a 6. 6 is larger. 2 goes into it evenly, so 6 is part of my lowest common denominator. Now, this one's a little bit different, right? Because I have an x plus y and an x minus y. Because they're both different, I need both of them. Okay? So this is my lowest common denominator. 6 times x plus y times x minus y. I have to have this. I have to have this. They don't have it in common, but that doesn't matter. That has to be part of my lowest common denominator. Okay? Number 5. X squared plus 6x plus 9. X squared plus 2x minus 3. So both of them need to be factored, right? Let's get my parentheses ready. X squared is a perfect square. 9 is a perfect square. 6 is positive, so these are both positive. So the first one factors to x plus 3 times x plus 3. The second one, x is a perfect square, but 3 is not, right? It's negative. What factors of negative 3, so I have one negative and one positive, are going to subtract and give me a positive 2? Well, it's going to be the negative 1 and a positive 3, right? It's the only factors of 3. Negative 1 times 3 is negative 3. Negative 1 plus 3 is a positive 2. All right, now let's see what we have. On this side, we have x plus 3 and x plus 3. We have 2 of them, okay? And this side, we only have 1. So we've got to take the 2 side, and I'm going to just write it like this, x plus 3 squared. That represents that we have 2 of them. And then we have this x minus 1. Okay, so x plus 3, we have 2. We have a squared here. It is bigger than just a single x plus 3. So that is the one we have to choose. Now, you could have written it x plus 3 times x plus 3 times x minus 1. That's fine. I just kind of combined it together just to save space. Okay. Number 6. X squared minus x minus 2 and x squared plus 4x plus 3. Factor, factor, factor. X is a perfect square. What factors? I need obviously one negative and one positive. Of 2 are going to give me a negative 1. Well, it's going to be a negative 2 and a positive 1, right? Because negative 2 times 1 is a negative 2. Negative 2 plus 1 is a negative 1. What about over here? My x is a perfect square. So factors of 3 that you're going to add together to give me 4, because I've got all positives here, right? It's just 3 and 1. All right. Let's take a look. X squared, x minus 2. I only have 1, so I need it. X plus 1, they both share it, but they each only have 1, so I just need 1. And x plus 3, I need that. So this becomes my lowest common denominator. It's kind of big, right? It's a little bulky, but that's all right. It's what it is. We've got to take this x minus 2. They both have 1 x plus 1, so we put that 1 here, and then this one has an x plus 3 that we need. All right? So we've spent a lot of time finding the lowest common multiples. This is really no different. It's just the fact now that they're kind of throwing these polynomials in here. They're making us factor first. That's really only the new thing that we're doing here. So we need to make sure we're including at least one of everything, right? Here we had 2 x plus 3s. This was probably the most complicated one. And so that 2x plus 3s was bigger than 1, so we had to choose that. Just like this m to the third was bigger than that m squared. If you think of what's inside the parentheses as just a variable, here we had 2 of them. So that's bigger than just the 1. All right, so that's why we have the 2x the squared. All right, that's lesson 8. Lesson 9 begins on page 43, and it's titled Quadratic Equations Solved by Factoring. Now, I've alluded to this in class before, that we've been factoring these, but we haven't actually finished the problems. So now that's what we're doing. We are going to finish the problem, okay? So that being said, let's take a look at what that means. It says a quadratic equation is an equation in which the highest power is 2, such as an x squared. Here are some examples. It says here that this first equation is written in the standard form for quadratic equations, where it's ax squared, so a being a constant, right, in this case a 1, bx, where b is a constant, in this case a 3, plus c, where c is a constant, here it's a -5, and it equals 0. All right. Quadratic equations usually have two solutions. That's what the x squared represents. The squared value in the quadratic equation makes it necessary to use special methods to isolate the variables and find their solutions. There are 4 methods. 4. The first is called factoring. It's what we've been practicing, right? So to use the 0, and we have to use this 0 product property with our factoring, okay? And it says to use the 0 product property to solve quadratic equations, the equation is factored. Then, because either of the factors must equal 0, right, because it says so right here, the factors are set up in equations to equal 0. So, x squared minus 5x minus 14 equals 0. They factored it to this. X minus 7 times x plus 2 equals 0. Because either this equals 0 or this equals 0, what we do then is we take this chunk and we set it equal to 0. And we take this chunk and we set it equal to 0. And then we solve for x. So we need to get the x by itself. To do that, we have to add 7 to both sides. And we get x is equal to 7. In this case, to get the x by itself, we have to subtract this 2 from both sides. And we get x is equal to -2. Now, if we went back to here and we put in a 7, it would equal 0. If we came back here and put in a -2 for x, it would equal 0. That's just the point, and that's what they do right here to show you. So there are 2 solutions for this problem. Is x equals 7 and x equals -2. All right? Both of those solutions solve this problem for 0. Let's turn the page. Now, the equation in the following examples are quadratic equations, but are not written in standard form. However, they can still be solved by factoring and setting up factors equal to 0. Solving the equation x squared minus 64, right? This is a sum and difference binomial. We know that because x squared is a perfect square and 64 is a perfect square, and we've got that beautiful negative sign. So here's what it factors to, right? We've done so many of these. And then once we factor it, we just set each part equal to 0 and solve. For this case, right, we're missing our constant term. So this one's a little bit different. What we have to do here is factor first, right? And so they factor out this x. So now it's x times the quantity, x plus 3. Well, we still take each part and set it to 0. Here, x is just straight up 0. And x plus 3 is equal to 0. And we solve. So the 2 answers are 0 and -3. All right. Now here at the bottom, it says that sometimes quadratic equations are not set up equal to 0, but can be transformed into equations that are. So here is the equation, right? Basically, we want to move everything to the left side of the equal sign. And once we do that, then we can factor, then we can solve. These are both the same, x minus 5 times x minus 5. So this solution is 5. Technically, it's 5 or 5, right? Because we need to have 2, but just because the solutions are both the same, you can just write 5. All right? Now let's take a look at these. We've done so much factoring. This should be a piece of cake, right? Solve quadratic equations by factoring. X squared plus x minus 2. So let's get our parentheses set up. Our x is a perfect square, so we split it. Our -2 tells me that I have a negative and a positive, right? But what factors of 2 subtracted from each other are going to give me a +1? Well, it's a +2 and a -1, right? So now equals 0. Now we need to solve. So we have x minus 1 equals 0 and x plus 2 equals 0. We have to add 1 to both sides to get this x by itself. So here x is equal to 1. And we have to subtract a 2 from both sides to get this x by itself. So x is equal to -2. Boom. Those are our 2 answers. Okay. This final step is like the easiest one. The factoring is the hardest part, right? But the final step, boom, and we're done. So what about this one? X squared plus 8x plus 15. Well, my x squared is a perfect square. This plus here and here tells me I've got two positives, right? What factors of 15 add together to give me 8? It's going to be 3 and 5. X plus 3 equals 0. X plus 5 equals 0. I have to subtract a 3 from both sides, so x is equal to -3. I have to subtract a 5 from both sides, so x is equal to -5. Okay. What about number 3? Well, I've got x squared plus 2x minus 63 equals 0. X squared is a perfect square. 63, of course, is not. It's a negative, so I have a negative and a positive. What factors of 63 subtracted to get from each other are going to give me a positive 2? Well, the only factors of 63 I can think of is 9 and 7, right? So a positive 9 and a negative 7 will give me a positive 2. So then I have x minus 7 equals 0 and x plus 9 equals 0. Adding a 7 to both sides gives me x is equal to 7. Subtracting a 9 from both sides gives me that x is equal to -9. All right, this step, I'm telling you, is like the factoring part is the hardest part, right? This step is the easiest part. So let's take a look at this one. We first have to write this in the correct order, right? X squared plus 20x, I put 2x for Pete's sake, 20x, and then I need to move this over, this 100, right? So to move it to the other side of the equal sign, I have to add it to both sides. So plus 100 equals 0. Now I have it all written out correctly, and I can factor. My x squared is a perfect square, and my 100 is a perfect square, and both of the signs are positive. So because x plus 10 is equal to x plus 10, I only have to do one. So x plus 10 is equal to 0. So x must be equal to a -10. Technically, it's -10 and -10, but just writing a -10 once is fine. Number 5. X squared. Remember, when we switch something to the other side of the equal sign, we just change its sign. When it crosses that line, you change its sign, okay? So this becomes a -8x minus 9 equals 0. All right, that's how we rewrite these. So now let's factor it. X is a perfect square. 9 is a perfect square. But we're not going to use 9 as a perfect square here. We need one negative and one positive. What factors of 9 added or subtracted from each other give me a -8? Well, it's a -9 and a positive 1. Sometimes they throw these little curveballs here. You've got to be paying attention. So even though 9 is a perfect square and we're tempted to write 3 and 3, that's not going to work out here, is it? But -9 times a positive 1 is -9. -9 plus 1 is -8. So here we go. X minus 9 equals 0. X plus 1 equals 0. So here, adding a 9 to both sides gives me x is equal to 9. And here, subtracting a 1 from both sides gives me an x is equal to -1. Rewriting this. Okay, when we cross this line, we change their sign. So now we have a positive x squared plus 10x minus 24 equals 0. All right, factoring. X is a perfect square. 24 is negative, so I have a negative and a positive. What factors of 24 added together are going to give me a positive 10? I'm thinking it's a positive 12 and a -2, right? -2 times 12 is -24. -2 plus 12 is a positive 10. Oh, I forgot my x, 10x, okay? So I have an x minus 2 equals 0 and an x plus 12 equals 0. Adding 2 to both sides, I get that x is equal to 2. Subtracting 12 from both sides, I get that x is equal to a -12. Okay, we do not have to go back in. If you're confident here, you don't have to go back in and check these. It should work out fairly well. So what do we have here? X squared plus 7x equals 0. I don't have my third term, right? But I can factor here. So I get x I'm going to pull the x out. That's what they have in common. And it leaves me with x plus 7 equals 0. So straight up, x equals 0, right? Anytime you have an x out here by itself, even if this is like a 45x, still x is straight up 0, okay? And then x plus 7 equals 0. Subtracting this 7 from both sides tells me that x is equal to negative 7. So I have x is 0, x is negative 7. All right, what about number 8? Well, number 8 is, hopefully you recognize it as a sum and difference binomial. X squared is a perfect square, so is 121. So it's a sum and difference binomial, and the square root of 121 is 11. So I have x plus 11 equals 0 and x minus 11 equals 0. Subtracting an 11 from both sides, here I get x is negative 11. Adding an 11 to both sides, I get that x is a positive 11. So whether it's positive 11 or negative 11, this becomes 0. This one's easy to check, right? Negative 11 squared is 121. 121 minus 121 is 0. Positive 11 squared is 121. 121 minus 121 is 0, right? Okay, beautiful. Number 9. 4x squared minus 49. All right. Hopefully you recognize this to be in the same thing we just did. 4x squared is a perfect square. 49 is a perfect square. This is a sum and difference binomial. 4x squared, what's the square root of that? Well, 2x, right? What's the square root of 49? 7. So now these are a little bit different, right? This is the first one they have this way. 2x plus 7 equals 0. 2x minus 7 equals 0. So here we have a little bit of an extra step. First, we have to subtract the 7 from both sides. So we get that 2x is equal to negative 7. Then we still need this x by itself. So we have to divide by 2 on both sides. X is being multiplied by 2, so we do the opposite and divide. And we get that x is equal to negative 7 halves. And just leave it like that. Please don't give me decimals. Please don't give me mixed numbers. On this side, I'm going to add 7 to both sides. So I get 2x is equal to positive 7. 2 is being multiplied by x. We're going to do the opposite and divide. And we get that x is equal to a positive 7 over 2. Okay? So this one was a little bit different because we had a coefficient in front of our variable. But that's quite all right. That's going to happen quite a bit. I'm surprised they only had us do 1 out of 9 that looked like that. This happens quite a bit. A lot of times fractions are what's going to solve this, okay? So when you get to this point, you solve it just like you would solve any other equation for x, all right? We've done these since the first day. We subtracted the outlier, right? It was positive in this case, so we subtracted it. In this case, it was negative and we added it, right? Then we did the opposite of whatever was happening to our variable. 2 is being multiplied by x. We did the opposite and divided, and we ended up with our answer. So factoring, setting each factor equal to 0, and solving for x is the name of the game here when we solve quadratic equations by factoring. All right? Great job today. That's it for this video. As always, if you have any questions, please shoot me a text. Otherwise, until next time.